I'm going to take you through the three methods to solve a system. I know you learned this in Algebra 1, so we're just going to quickly review how to solve systems. So the first method that you learned is just simply to be able to graph and then name the point of intersection. So for this first one, and then I want you to try the evens on your own. So I'm going to take you through the odds, and then you do the evens. So for this particular line, we want to start at 2, so I'm going to put a dot along the y-axis at 2. And it has a slope of up 5 over 4. Now, I don't have quite enough room to go up 5 and then to the right 4, so I'm going to count down 5. 1, 2, 3, 4, 5, and then I have to go to the left 4. 1, 2, 3, 4. Okay, so it's still going uphill at a rate of up 5 over 4. Where the other line, we have a starting point of -4, and it's going downhill of down 1 over 4, okay, or you can go up 1 over 4. And then where they intersect is our solution, okay? So you want to name this point, so don't just stop here. You want to actually name the point. So in this case, my x value is -4 and the y value is -3. Okay, so if you would substitute a -4 in for x and calculate, you would get a y value of -3 for the top. When you plug it in here, you're going to end up getting 1 minus 4, which is also -3. So it makes both equations true. Okay, so this is your answer. So it's a nice visual. You can do this on a calculator if you wanted to. Then the next method is called substitution. So with substitution, you have a couple steps to do. The first step is to get a variable by itself. Now, in some cases, like when you do number 4, I already have the y by itself, so you can just simply substitute. So for this problem, though, I want the easiest variable to get by itself, meaning it should only take you one move. So this x right here is going to be the easiest one to get all by itself, where this x would end up having to divide by -2. So first step, get a letter by itself, easiest one. So in this case, I just have to add 3y over here with the -8. Okay, so step 1, done. We have a variable by itself. And then step 2 is why we call it the substitution method. It's going to be substituted into the other equation. So I'm going to replace the x. So I have -2 parentheses minus 7y equals 3x. So instead of this x, we're going to put in what x is equal. So x is equivalent to a 3y minus 8, and that gives us an equation with just y. So that's how you know you did this correctly. If you get to step 2 and you still see two variables, you didn't substitute correctly. So we should be able to solve for y pretty easily. So a lot of you did this in chapter 1, where I get -6y plus 16 minus 7y equals 3. When you combine this, you'll have -13y, and then I'm going to subtract my 16 right away, and I'll get -13. 3 minus 16 is -13. Last move is to divide by -13, and you're going to see that y is 1. So then you can't stop there. Even though y is 1, you need to tell me what x is, so this just simply gets placed back into step 1. So x is going to be 3 times my y value, which we just calculated to be a 1, and then we're subtracting 8. So you just calculate that. It's 3 minus 8, which is -5. And then just write it as an ordered pair, -5, 1. Okay, and it's always a good idea to just quickly substitute in. If I put a -5 here, I'm going to get 10 minus 7 times my y value of 1. 10 minus 7 is 3. It makes the top equation true. If I plugged in a -5 here, I have -5 minus 3 times 1, which is -5 minus 3, which is -8. It makes both true. Okay? The last method to review, and then like I said, I just want you to attempt the evens, and then we'll go over this the next day. Okay? So this last method, this is probably everybody's favorite method, and it's called the elimination method, where you want opposites. So the first thing we need to make sure is everything's lined up. So all my x's are lined up, my y's are lined up, and my numbers. So if it's not, you have to use your algebra skills to get it lined up, but they're lined up. 6 is also lined up. So you have to get opposites by thinking of multiples. Okay, so I can get my x's to be opposites. Right now I have a 2x and a 1x. Well, if I multiply this bottom equation by -2, so you'd have to multiply everything in the bottom by -2, then my x's would cancel out when I add the two columns. So I could also get the y's to cancel out, and that's what I'm going to do. I'm going to multiply the top by 2. I'm going to double everything in the top. So 2x times 2 is a 4x. This 8 times 2 is going to be a 16. So it's 16y equals -12. Again, don't forget to multiply everything by a number. And the reason I wanted to double everything is my y's are going to cancel out. My y's are opposites. So once you have opposites, you just simply add your columns. So 4x plus 1x is a 5x. The y's disappear when I add my numbers. And again, if you need to, use a calculator, but this is going to end up being -35. And when we divide, just like that, we know that x has to be a -7. Okay, and then once you know one of your letters, you're simply going to substitute it into either equation, whatever one looks easier. I'm going to plug it into the top equation. I'm going to take 2 times -7 plus 8y equals -6. This is -14 plus 8y equals -6. All I have to do is add a 14, and I get 8y equals 8, divide by 8, and I get y is 1. So answer -7, 1. Okay, and again, it's a good idea to substitute in just to double check. If I plugged in a -7 for x, -7 minus 16 times 1 is -7 minus 16, which is a -23. It makes both equations true. Okay, so hopefully that brings back memories of when you solve systems in Algebra 1. So we're going to spend, several days reviewing all this, giving you plenty of practice to perfect these 3 methods to solve a system. Okay, thanks for watching. Take care.